Good morning, dear students. My name is Ferhan Mazher, and today is 10th of May 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. And today, we have set our hearts to solve ATP paper, and we have selected May June 2013 for two paper. This paper 4 belongs from the Zone 2 or the Variant 2. The time allowed for this paper is 1 hour. So let's start this paper. So here we go. So the May June 2013 4-2 paper. A student determines the focal length of a lens. The apparatus is set up as shown in the figure 1.1. So here we have a holder in which we have a lens, and here we have an illuminated object. Here we have a screen, and that is also on a holder. And all these things are moving along a meter rule. The image formed here is blurred, and he says the illuminated object is fixed at the 0 degree centimeter mark on the meter rule. The perpendicular distance u of the object from the lens is fixed at 15 centimeter. This distance, we will not change this distance. This distance is called u. So on the figure 1.1, mark the u and label it at 15 centimeter. So from here to the exact to the middle of this thing, you will make a line here and we will write 15 centimeter. This is representing u. So let me show you. I have done this. So you can see here I have tried to draw this. U is equals to 15 centimeter. So the next thing they are asking is, it says the image on the screen is not clear and the center of the image is above the center of the lens. So explain how the apparatus is adjusted to produce a focused image on the screen. We can move the screen forward backward along this rule. So where the image will become clear, you can stop it there. And another thing which you need to do is raise this illuminated object upward. Raise it upward so that it becomes in the middle of the lens. So this is what you have to do in these two parts so that the center of the image is level with the center of the lens. So first part, second part, I'm giving you these answers. Okay, so from the, here you go. Move the screen forward or backward along the meter rule until you get a clear image on it. Raise the object until center of the image is level with the center of the lens. That's my answers. Okay, so let's have a look at the marking scheme, what the marking scheme has to say. Okay, so that's the marking scheme. So you can see the same answers we have here. Okay, so it says the image on the screen is in the focus and the student measures the distance from the object to the screen. And figure 1.2 shows an enlarged view of the part of the screen and the meter rule. And state the reading on the meter rule at the position of the screen. This reading is 45.1 centimeter. So here you will write 45.1 centimeter. Use your answer to see first part to calculate the distance v of the image from the lens. The distance of the, because this is 45.1 centimeter, this is 15 centimeter. So the distance between them and between the screen and the lens is v, and that will be 45.1 minus 15. So let me show you my work. 45.1, and this reading will be 45.1 minus 15, and that will be 30.1. So 30.1 centimeter will be the answer. So in this table, and the student repeats the experiment to increase the value of the u. Let me show you the paper. And he says, okay, so it is 15 and it is 30.5. That's the value which we got. 30.1, sorry. 30.1, sorry, I said 30.5. Okay, so 30.1, and here you will write 15. So in the space in the figure 1.3, write your values of the v for the second and corresponding values of the u. On the figure 1.4, plot the graph of v in the centimeters on the y-axis against the u in centimeters on the x-axis. Start your graph from v equals to 10 centimeter and u equals to 10 centimeter. So let me reduce the size. So you see both these axes, they are starting from the 10. Okay. So let me show you my answer. So here you can see I have labeled this. Here on the x-axis, we have represented the u, and I have 10, 15, 20, 25, 30, 35, 40, 45. On the y-axis, we have v in the centimeters, 10, 15, 20, 25, 30, 35. And then I will plot these points and I can show you. At 15, you have 30.1, and at 20, you have 19.8. 19.8 will be here somewhere. So at 25, you have 16 points. Yeah, that will be this point. And at 30, you have 15.1. And at 35, you have 14.2. And at 14, you have at 40, you have 13.3. At 35, you have 14.2. Okay. Then I join them with the smooth curve. Okay. So the next, so C part and the D part is showing up, the marking scheme. Okay, so we are going to the next part. He says, suggest two practical techniques that the student uses to make the reading for the V as accurate as possible. You see, one method is for getting an accurate answer of the V is you repeat the experiment 2 times or 3 times, and you get the value of the V every time, and then you take the average of the V. So repeat the experiment and take the average value of the V. The second thing can be that whenever you take the reading from the scale for the V, your line of sight should be perpendicular to the scale from where you are reading it, and it will avoid the parallax error and your answer will become more accurate. So these are my answers. So let's have a look at the marking scheme. So here a list of the things are given. You can pause the video and you can read them. I have already checked my answers. Okay. When the U and the V, they are equal, theory shows that the focal length of f of the lens is given by f is equals to u by 2. Use your graph to determine that value of the f. So if I go to my graph, where the u and the v value is same. If you look at here on my graph, here at this point, the v value is 20, the u value is 20. So this is the point. So here the u value is 20. He says that f is equals to u by 2. So f will be equals to u by 2 means 20 by 2, and that will be 10 centimeter. So the f value will be 10 centimeter. So let's have a look at the marking scheme. F will be 10 centimeters. So our answer is right. Okay. Now, a student walks to school. He sketches a distance time graph of his journey. Figure 2.1 shows the first part of the journey. So this is a distance time graph. On the y-axis, the distance is represented. On the x-axis, the time is represented. And time is in minutes, and the distance is in meters. So this is 500, this will be 1000, 1500, and that will be 2000. 5, 10, 15, 20, 25, and 30. Okay. He walks, they say that he walks 500 meter in the first 5 minutes. That is already shown in the figure 2.1. He then meets a friend, and as they talk, they take 10 minutes to walk the next 500 meter at a constant speed. So let me show you how I showed it. So at 5 minutes, he met his friend, and then they walk with a constant speed. And after 10 minutes, they have covered further 500. So from 500, they have covered 500 more. So now the distance will become 1000. So at 15, 1000, I will put a dot and I will join them with a straight line. Then what happens? Then they stop for 7 minutes to look at some fish in a river. They ran at constant, so for 7 minutes. So this is 7 minutes. They have stopped there to see a fish. And then they ran to their school and they covered 500 meter. And at in 25 minutes, the total journey is completed in 25 minutes. So at 25 minutes from here to here, at 25 minutes, they have completed the journey. That's so further 500 meter they have covered. So I put a dot on 25, 1500. I hope you understand this story. On the figure 2.1, plot the remainder of the journey. We have plotted it and state the total distance the student travels to school. So the total distance they have covered is 1500 meter. So 1500 meter is the answer. So let's have a look at the marking scheme. So you can see 5, 500. This is already plotted there. 15, 1000. Yes, we have done this. 22, 1000 and 25, 1500. We have plotted these points. Our distance is 1500 meters. So our answer is right. Okay, sir. So there's a method of measuring the distance traveled by the student to the school. The one method of measuring the distance from their home to the school is they can use a trundle wheel. Trundle wheel is a wheel with the handle, and every time the wheel completes a revolution, a sound is produced. And what basically we do, we will take the trundle wheel with us when we are walking, and when you reach your home, up till that you count how many counts are there, how many clicks are there, sorry, and then multiply the number of the clicks with the circumference of the wheel, of the trundle wheel, and that will give you the distance you have moved. So let me show you my answer. Use a trundle wheel, walk the path with the trundle wheel and note a number of revolutions the trundle wheel has completed. Multiply the number of revolutions with the circumference of the trundle wheel. So normally, actually, what happens in real, that trundle wheel has a counter on it, and it will do it automatically. But this is actually what is happening. Okay, so let's have a look at the marking scheme. It says use a pedometer, measure one pace and count the paces, and tape measure with repeated use described use of the trundle wheel. So we have used the trundle wheel. Without calculating any values, explain how the graph is used to find his fastest speed. The fastest speed in this graph, let me show you the graph which I have drawn. The fastest speed, this is because this is a distance time graph, and the gradient of the distance time graph is equals to speed. So wherever the gradient is steepest in the distance time graph, there the speed is fastest. So our answer is where the gradient of the distance time graph is steepest, speed is highest. That's my answer. That was the okay. So let's have a look at the marking scheme. And where the steepest largest gradient. So that is the answer, C part. Okay, so we are going to the next question. The next question coming up on your screen is figure 3.1 shows a bottle with a solid glass stopper. So this is the solid glass stopper. This is the bottle. Describe a laboratory experiment to determine the volume of the glass stopper. In your answer, state clearly the equipment used, the readings taken, how the volume is calculated. It's a 3-mark question. Okay, so let me show you my answer. So for this, we are going to use our displacement can. Displacement can is a simple can with a spout. So what we do, we fill the can with the water up to the level of the spout. And we put under the spout a measuring cylinder, and then we put that glass stopper in the displacement can. When you put the glass stopper in the displacement can, the level of the water in the displacement can will go up. It will go up, and because the water displaced by the glass stopper, that through the spout will be collected in the measuring cylinder. So whatever is the water collected in the measuring cylinder, from that measuring cylinder you can check how much water is displaced. So whatever is the volume of that displaced water, same is the volume of the glass stopper. So I have written, so fill the displacement can up to the level of the spout with the water, put glass stopper in the displacement can, water displaced from the can will be collected in the measuring cylinder. Volume of the water in the measuring cylinder is equals to the volume of the stopper. It's a 3-mark question, so that is our answer. So let's have a look at the marking scheme. I have given this answer. Measuring cylinder stated, fill can to spout, immerse the object, find the volume of the water collected. So our answer is right. Okay, so that was a 3-mark question. Describe one way to make the measurement of the volume accurate. So one way of the making the measurement of the volume accurate is repeat, find the volume, for example, 3 times, and then take the average of that volume. That's one way of making it more accurate. Repeat the experiment and take the average value of the volume of the glass stopper. That's my answer. So let's have a look at the marking scheme. What the marking scheme says. It says sensible suggestion, repeat measurement of the volume and average, avoid the parallax reading measuring cylinder or eye line of sight perpendicular to the scale or the reading view level with the lower meniscus, avoid splashing. Yeah. Okay. To determine the density of the glass in the stopper, one more quantity must be measured. State the name of this quantity and the instrument used to measure it. You know the density is equal to mass divided by volume. So another quantity which we need to measure is the mass of that glass stopper. And for that purpose, you can use the electronic balance or pan balance or simple balance. Mass and balance is the right answer, sir. So let's have a look at the marking scheme. It says mass balance. Okay. Now we are going to the next question. The next question is a solar cell converts the light energy into electric energy. A student investigates the maximum EMF produced by a solar cell in the laboratory. Figure 4.1 shows the symbol for a solar cell. So remember this cell and then this light symbol, 2 rays, and that shows the solar cell. The student uses a voltmeter to measure the EMF produced by the solar cell. Draw a diagram of the circuit he uses, include a switch in the circuit. 1-mark question. So what we'll do, we will show solar. So here you have to put us 2 arrows here of the light of, okay, I forgot to put them here. So cell, and here is the switch, and you have put a voltmeter parallel to the cell. So that will tell you the EMF of the cell. And I'm telling you, I just made a mistake. Put 2 arrows of the light here. Okay, so if you have the hard copy with you, so to show that this is solar cell, you have to put 2 rays of light here. Okay, then he says when the student closes the switch, he notices that the voltmeter needle moves backwards as shown in the figure 4.2. If when the needle is going, instead of going into this direction, it is going in the opposite direction, it means that on this positive you have with the battery, the voltmeter connection with the battery, they are wrong. So you have to reverse that connection. Okay, so let me show you my answer. It says connection to voltmeter needs to be reversed. Connections are wrong. Okay. So let me check. The voltmeter terminals to wrong terminals of the cell, current in the voltmeter in the wrong direction, voltmeter has polarity. Reverse the connection to the voltmeter, reverse the connection to the cell. Okay, red connect red with the positive terminal of the okay, so here we go. The student corrects the problem, and when the switch is closed, the voltmeter now reads 0.96 volt. On the figure 4.2, mark the new position of the needle. So 0.96 will be here. Let me show you. So you have to put an arrow here. This will be 0.92, 0.94, 0.96. So you have to put an arrow here. Okay. Up to 0.9. This is 0.96. So let me show you. I have done this. I have done this. So you can see this. This is what they are asking. Okay. So then he says, to investigate the solar cell, the student uses the light entering the laboratory through a window. When the student moves his head to read the voltmeter, there is a large decrease in the reading. So there's a reason for this, and explain how the student can prevent this happening when he moves. So I think that when the student moves his head came between the light coming from the window and the voltmeter, and the shadow of his head has been casted on that solar cell. So because now the light falling on the solar cell has decreased, that's why the EMF produced by the solar cell has decreased. To avoid this, the position of the student should be such that it should not hinder the path of the light. So when the student moves his head, shadow of head is cast on the solar cell. Due to less light, EMF reduces. Head should not come in front of the source of the light, or anything should not come in front of the source of the light. That's my answer. So let's have a look at the marking scheme, what it says. Movement of the head body reduces the amount of light falling on the solar cell. Head body not between the window, light source, and cell. Sensible square, for example, position of the solar cell, other light sources considered. You can also put the solar cell in such a way that the more light falls on it, or you can switch on more sources of light there, or you can open more windows. So, my dear students, today we have done May June 2013 of 4-2 paper. We have completed that paper, and I think I have tried my best to best of my abilities to explain you the concepts. If you find this video interesting, informative, and helpful to you, please share the link of this video onto your Facebook, onto your Twitter accounts, and onto your Instagram accounts. Also share the link of this video with your junior students. So it's a great blessing for me to be able to teach you online through this YouTube channel. Thank you very much. Have a good day. God bless you.